So as Roger mentioned, this is the last webinar in the series, and we're going to cover the last component of Shiny apps, which is how to stylize the apps and customize their appearance. Just as before, I've put these slides online. In addition to being in the GitHub repository that we make for this webinar series, these slides will also be available from the short link bit.ly Shiny Quick Start 3. And just like in the last two webinars, we're going to look at some very basic Shiny apps. I'm trying to break it down as simple as possible to make it easy to learn the parts of Shiny separate from each other. But of course, when you put all this stuff together, you can make really sophisticated and impressive apps. And if you want to see what those apps look like, then I recommend stopping by the Shiny Showcase, whose link is right here. So again, this is the last webinar in the series. The other ones are available online, so if you haven't watched them before today, you can go back and see them later, and soon this one will join those as well at the same website. So here's what we covered so far, just a reminder of what we did in the past 2 weeks. In the very first week, we learned that a Shiny app has two parts. It's a web page that people can visit, but embedded in that web page are things they can manipulate and outputs of R analyses. And behind the web page is a server, a computer that's monitoring the web page with an open R session that's ready to run analysis in R whenever it needs to update that web page. And by working together, these things create an interactive web app. We learned how to share apps through shinyapps.io or to set up your own server, either the open source or professional version. We learned how to start building apps with a useful template that you can use over and over again. The first part of the template sets up the web page that your users will visit, and the second part sets up the server to manage that web page and create interactions. In the second webinar, we looked at all the ways you can control the reactions in your Shiny apps. Today, we're going to look at the last component. That's to take your basic Shiny app, which looks like the app on the left, and manipulate the appearance so it looks like something more impressive, like any of these apps we see here on the right. And what we're going to use to do that is the underlying HTML UI of a Shiny app. So we say in a lot of places that you don't need to know HTML to make Shiny apps, and that's true. And you'll see today that you don't necessarily even need to know HTML to use the stuff we talk about today. But of course, HTML does underlie everything that we do here because we are working with web pages. And the more you know about it, the easier you'll find it to navigate the appearance of your app. Now, I don't write web documents myself, but I do know HTML, I do know CSS. I just rarely have a chance to use it, so I often forget it. And what I found is that all these things are very well documented online, and you can search for anything on Google very easily. So recall that the user interface of your app that we've been making with Fluid Page is really just HTML. We use R functions to make it, but these R functions, if you ran Fluid Page at the command line, you'd see they're just returning HTML. We could pay attention to that HTML, or we could ignore it. It doesn't matter. We've seen before that you could, call Shiny functions to add inputs and outputs to your user interface, and those functions themselves, they're also just calling HTML or writing HTML. So this idea that you call R functions that return HTML to build the app is something we'll return to throughout the day. This is a basic paradigm for setting up the appearance of your Shiny app. You call an R function, and that function writes the HTML for you. So just realize that we're going to be calling R functions to work with HTML. Fluid Page is a quick way to set up a user interface for your app. And then we already know that you can use input and output functions to create the reactive components for your user interface. And then finally, you save that output to UI if you're using the template that I recommend you start with. So you know from the previous webinars how to set up reactive content in your user interface, but you can also add static content. This would just be purely visual content to your app. And we're going to look at how to do that. Now, since your app is a web page, we might start by considering how would you add content to a normal web page. And if this is our web page, we have a basic Fluid Page here, looking at the HTML side of it, we might add a title to it by using the HTML tag h1. It makes a first level header. We could add a paragraph of text with the HTML tag p. It stands for paragraph. And inside that paragraph, we can nest another tag. A is the anchor tag, or it's the tag you use to make web links. When we do that, our app will have a web link on the side. And then if we wanted to stylize something, like if we wanted the text in our paragraph to be a little different, then inside that paragraph tag, we could add some style. We could add a style argument, or in HTML it's called an attribute. And here I'm just setting the font to the impact font. And so it changes how the font looks. So this is how you do it with HTML. You use these things called HTML tags. Well, we're not going to be writing HTML. We're going to be writing R. And in R, you call a function that recreates the HTML tag. And Shiny comes with something special. It's a list of functions that's saved under tags. So this tags object will be a list of functions. And then within that object, there's a function for every HTML tag that you could create with HTML. So if you know HTML, you can just map onto your knowledge that you already have. And if you don't know HTML, you could just learn with me right now the most common tag functions that you're likely to use. And then if you ever want further guidance about what to do, you could Google HTML tags to see what's out there. Or go to the Shiny Dev Center where I've written an article about all of this. So this tags object is a list, and it contains 110 elements for 110 different tags. We're just looking at the first 40 or so here. And you can see that each of the elements has the name of an HTML tag. For example, we see right away that A tag we looked at earlier. It makes a web link. It's a little unusual, this object, in that it's a list, which I'm sure we've all used in R before, but the elements of the list are themselves functions. That's completely permissible in R. Don't be worried about it. Don't let it distract you. If you were to look up one of the elements in the list using list syntax like tags $H1, it will return the same thing that would happen if you just typed in the name of a function R. Say you typed in the name of a function mean. You don't put parentheses behind it. R doesn't run the function. It shows you what code is inside the function. So here's the code that's inside the H1 function. I show you this because this is probably not really what you ever want to do, but it might happen. If you want to use one of these functions in the tags list, just refer to it the same way, but put parentheses after the function. This is how you trigger the code in a function to run when you use R. So now if I run tags $H1 with parentheses, it actually runs that function. And what that individual function does is it just inserts an H1 tag somewhere, not surprisingly. So these tags functions have their own syntax. They're all part of the tags object, so you have to find them there. In many cases, you couldn't write something like table, which is one of the tags, and expect to get the tags function that creates a table. R has its own function that does things related to tables, whose name is table. So you need to use the tags $sign to specify that you're specifically talking about these Shiny functions that recreate HTML tags. Once you do that, you choose the name or the element of the list that you want to use. The name will correspond to the HTML tag that you're trying to make. So here I'm calling A, and that will make an H tag. By the way, this HTML at the bottom of the page is the output of the R code at the top of the page. Next, you could give the tag named arguments, and any named argument that you give to the function will appear as an attribute of the tag. So notice that href down below is in between the braces, or the less than sign and the greater than sign. This is where HTML attributes appear. When this A tag goes into your website, your viewer won't actually see www.rstu.com. That's meta information that the tag uses. In this case, when the user clicks on RStudio, it will take them to the website, www.rstu.com. So the way you add those attributes is you pass them to your tags function as a named argument. If you pass arguments to the tags function that do not have names, then the function will put it in between the tags or inside of the tags in the HTML. So here, when I write RStudio with no name, it becomes the text that goes inside the A tag. And for the A tag, that will be the text that your viewer sees and can click on. It will normally be blue or underlined, something that tells the viewer that's an active web link. Now, one thing that you could pass to a tags function is a second tags function. You can nest them together. And I have a slide that shows what that looks like. So how would you use these things? You could call the tags function inside Fluid Page in the UI of your app to start adding different tags. Here I'm adding 1st through 6th level headers using the functions H1 through H6, which all exist in the tags list. If you want to make a web link, you do that with the A tag. And every web link will need an href, that's the URL that the link will go to when you click on it, and then a piece of text to show as the link. You could write text without calling a tags function. If you just pass a character string to Fluid Page or any Shiny layout function, that text will appear right in your app. But if you want to organize the text into separate paragraphs, you could do that with the p tag. So now the same text is 2 paragraphs. And if you want to make italicized text, you could do that with the EM tag. It stands for emphasis. The strong tag makes bold text. The code tag makes text that looks like it's code. Depending on what sort of web browser or styling, we'll talk about that later, you're using, it may or may not show up pink like this, but it will look mono-spaced code-like text. And then you can S tags together. So here's the P tag that makes a paragraph, and I'm actually passing it 3 unnamed arguments. They're all unnamed, so let's go knit them together to be the text that appears inside the P tag. Well, one of those arguments is a second call to tags. In this case, it's a call that makes some bold text that says shiny. And you can see how this comes to appear in our app. We have a paragraph. One of those words is bold. The rest is, as you would expect. The BR tag inserts a line break. The HR tag inserts a horizontal rule. So if you'll look closely at the app, you'll see there's a slight gray line going across. That's what HR inserted. And then a popular thing to insert into web pages, certainly, and Shiny apps are images. And you can do that with the IMG tag. It's a little different than the other tags in that every argument needs to be named. It's very common to put a height and width in there in pixels, the height and width of your image. But then the essential argument with image is SRC. It stands for source. And that is a link to the file that actually contains the image that will appear there. You could set source to a URL if that URL contains an image, like if it links to a PNG or a JPEG or whatnot. If you go to this URL, you will actually see, I'm pretty certain, this R-orb, although don't take my word for that. More commonly, instead of linking to an image that's already online, you might link to an image that you yourself own and have on your computer. If you want that image to go inside your Shiny app, then there's a special way to include it with your app. Inside of the app directory folder, whatever you've named the directory that contains your app.r file, and the other files, make a folder called www. Use that name specifically. Shiny and Shiny servers, when they deploy your app, all of the files that appear in the www folder, the server will make accessible to your user's web browser. And so your web browser is what's going to assemble the app on their end. And if you want an image to appear in the app, the web browser is going to need a copy of that image. Later on, when we work with CSS, we'll need a copy of the CSS files and whatnot. So the first thing you want to do when you want to share an image to include in your app is make a www folder and put it in that folder. And then once you've done that, you can just use the file name of that image as the source argument for that image to appear in the app. Now, one thing you'll notice if you download the course materials today, and the link's at the top of the slide right here, you have a PDF copy of all these slides, but in there, there's also, I'll show you. When you first download it, it'll look like this. You'll have the PDF slides in the code folder. And inside the code folder are many examples that parallel what we're talking about today. We have an example of making a Shiny app with just pure HTML. So you can open that in the editor. We have a Shiny app that creates that HTML using the Shiny tags here. And then we have this app directory. And what app directory is it's basically the directory I showed in the last slide. We have a script here for an app. And this app uses an image. This image is called bigorb.png. It has a www folder, and in that folder is that image. So you can see this is how we would include an image in this app. And if I were to run this app, you'll see it doesn't do anything really, but it does contain this image that was in the www folder. Also notice you don't need to put www/ in front of the image. Source will look for it right in the www folder. If you have a subdirectory inside that folder, then you would put the subdirectory name. Think of this as the file path that goes from www to your image.
So all of these functions are available in the tags list, which means you could call them with tags, $, and then the function name. But for the most useful functions, and the ones that don't conflict with our names, or the names of functions that already exist in R, we've gone ahead and made wrapper functions that you can use to access the function in the tags list.
And for example, h1 is a function that comes with Shiny. It's a wrapper for tags $h1. And it's just a way to save you typing. You could call h1 instead of tags $h1. You can see right here in the code, it's just going to call that for you. And so when you're working with the most common tag functions, you could resist writing tags. Now, there's no real rhyme or reason which ones have wrapper functions, which ones don't. It depends on what already existed in R and whatnot. So tags will always work, and then you'll find through experimentation you don't need to call it all the time. So these are probably the most common, the most useful tags functions. They all have helper functions or wrapper functions, so you don't need to call tags in front of these ones. And they're just the ones we went over in the slides. So here's the app I showed you before. And if you go to RStudio and you actually took this code and saved it in the RStudio IDE, then you'd have basically what we have up here in the first file, tags. Look at it over here. One cool thing about the RStudio IDE is that if you have an HTML file and you have HTML in it, you save it with the extension.html. RStudio knows it's HTML and it will actually preview the HTML for you. So if we want to see what this code looks like in a real web page, we can just click preview, and there it is. This web page isn't that fancy, but this is really useful if you like working with HTML. Going back to the slides, we could recreate everything that's here just using the Shiny tags functions. And this is the paradigm that you use with Shiny. So, instead of writing div, we could call fluid page. We could call h1 to make that h1 header. Now, one thing is, since this is R now, when we want to pass that text h1, we put quotation marks around it. You can see here with the HTML, that's not a consideration, but that's okay. To make that paragraph, we could call the p tag. We could call the a tag to make the link. And then when we're done, our web page will look like this. You'll notice it's a little different, and that's just because, well, frankly, the previous version was kind of ugly, and Shiny comes with some basic styling that tries to make everything pleasant looking. But you can see we're still using the fonts we asked to use, and we still have our links and our headers and everything we asked for. And then, of course, we could do all this using the tags syntax to access those functions as well. And then there's one other way we could go about this. This is all HTML here. It's legitimate HTML. And you could pass HTML straight into a Shiny app, and then Shiny will use it to build the web page. The way you do that, perhaps I shouldn't say straight into the Shiny app, is you pass it to a function called HTML. So first, make it a character string. Here I'm using a single quotation mark to make this a character string. And then passing it to the HTML function. And then Shiny will parse that as HTML. We've told it through the function that this is actually HTML. It's not text we want to appear in the app. And then we'll end up with the app we see here on the left. So the way that HTML function works is you just call it, it's all capitals, you give it a character string that contains raw HTML, and then Shiny will interpret that string as raw HTML and put the results into your UI. All right, so let's recap what we've learned there. You add elements with the tags functions. They appear in the list called tags, and you access them with list syntax, tags $. For each of these tags functions, it will take unnamed arguments and pass them through inside the tags. It will take named arguments and pass them as HTML attributes. So if you want to know which named arguments you could use for a given tag, just look up that HTML tag and see which attributes it works with. And then finally, you could add raw HTML with the HTML function. Now at this point, some of you, perhaps 60% of you based on that poll, will say, hey, I already know how to use HTML. Why do I need to relearn how to recreate it with R? Can I just make my UI from HTML? And the short answer is yes. This slide is for you. It links to an article that explains how to just start with an HTML document and to add the Shiny components to that, so you don't have to write the UI in R. That said, however, even if you know HTML, I recommend that you use these R functions. or at least try them out and give yourself a chance to get comfortable with them. Because I think it's easier in the beginning to stick with one language, R, since you have to write R for the back side of the app anyways, than to go between two different languages. But of course, you have your freedom here to do what you prefer. So the other thing that web documents do, or HTML does, besides adding elements to a web page, is it lays out those elements. And that's not something we've really looked at yet in our Shiny apps, but it's certainly something you can do. Picture this gray box here as being your Shiny app, and we want to put this slider into it. Well, you have the freedom to place that slider anywhere you want in your app based on a grid that has, an X dimension. So you could place the slider on one side, move it to a different place. And we can also move it up and down in the app based on the Y dimension. So we have a little bit of freedom of where we place our elements. And then if you think of the app in 3 dimensions, so for example, we might stack some elements on top of each other. You can only ever see the top one, but you might be able to change which ones are on top. Then you could also think of your app as having a Z dimension, and you can determine where in the app to place your elements on the Z dimension. The way we're going to do this is with some functions that also create HTML, and they exist purely to create layout for your app. So these functions return divs, an HTML division, and the divs are set up in a way that it breaks your app into separate dividing spaces, and then you decide which space to put your elements into. And the 2 main functions are fluid row and column. So let's take a look at those. Fluid row will divide your app up into rows. So this is like a horizontal strip. And you could add as many as you want. Every time you call fluid row, it'll add a new row to your app, and the new row will appear below the rows that are already there. So this UI code over here would divide your app up like this. Now you won't see boxes with blue dash marks and the words row 1, row 2. This will be invisible divisions, but I want you to see how it gets divided up, so that's why those are there. The fluid row functions work together with the column functions to create a space to place each of your elements. You could pass an element straight into fluid row. To be honest, on its own, fluid row doesn't really do much. If you don't use fluid row, R is going to stick your elements in there one on top of each other, and if you do use fluid row, it does the same thing. But when you add column to fluid row, now you have a complete system. What column does is it creates a space inside of a row that has a certain width, and then you could place your apps inside the width. So for example, here I'm calling 3 different columns and 2 different rows. The first argument of every column is a width. Every column has a certain width in units, and the way those widths work is based on a base 12 system. So no matter how wide your app is, the row is considered to be 12 units wide. And the width argument of a column determines how many of those 12 units you want the column to take up. So in the top row here, we have one column that takes up 3 of those 12 units. And then the next column will be inserted right next to it, and it will take up 5 of those 12 units. So you can't have a column that's more than 12 units, obviously, and I've never tried it. It just occurred to me you could try it, but I don't think you can have a column less than 1 unit either. That wouldn't make any sense. As the breadth of the window changes, the width of those columns will change relative to the window fluidly. That's why everything says fluid over here in the UI. The second argument that a column can take is an offset argument, and that inserts a number of units between the left-hand side of the page or the end of the previous column before this column starts. So this last call to column here offsets that column by 8 units, pushing it all the way over to the edge of the page. Again, you won't see any of these blue dots or blue areas in your app. All these divisions will be invisible until you start putting things into them. But now we've created this setup, let's look at how we can use it to put elements into our app. And then also, just remind yourself, these things are just writing the HTML for us. This is just working the way HTML normally works. All right. If you want to put something into a row, then you could just pass it as text to fluid row, and it'll appear inside that div, which means it'll go wherever that div is in the app. If you want to put something inside a column, then just pass it as an argument to column, and it will appear inside the div that makes that column. So this second div in the blue down here, that's the output of plot output, just to remind you. So it's putting whatever plot output outputs into the div that goes along with that column we created. So if we go back to the layout that we made, uh, we could put a slider input, just gloss over the arguments for slider input, into our second column there by passing it as an argument to the second column function, and that's where the slider input will appear in our app. We could put a histogram into the third column just by passing it as a new argument to that column, and it will appear over there in that column. And when we're done, our app will look like this. Not really that impressive, kind of samey, but this is the system that you would use to place things where you want them in your app. And you could pass more than one thing into a column. You could pass more than one thing into a fluid row. R will just stack them on top of each other and fit them where you've asked them to be. They'll share that space. Fluid rows will expand their height to accommodate whatever happens to be inside them, and pretty much the same for columns. So let's recap that system. You could position your elements in a grid in your app, or you could stack them on top of each other in layers. So that's how you lay out your app. We haven't looked at layers yet, but we'll get to that. Use fluid row to arrange elements in rows. Use columns to arrange elements in columns. And then you can position columns where you want them in your app along those rows with the width and offset arguments. The width argument is mandatory. You have to use that. The offset argument is optional. So now let's look at how to stack those layers of panels into your app. That'd be the Z dimension I talked about earlier. So panels are a thing in Shiny. They're the basic unit of grouping together elements. And when you group elements together into a panel, then they act as a single element for you to place in your app. And usually that panel element will have some unique properties of its own. So for example, what we see here is a title, action button, a button called action, a horizontal rule, some text, some display, and another button that have all been grouped together as a single element into this panel. In this case, it's a well panel. And if you visit that link, you'll see there's an app here that sort of demonstrates all the different input objects you can use in Shiny, and it relies heavily on grouping things into these well panels. So a well panel is an example of a panel. The way you create one is with this function well panel, and this code I'm showing you is one of the example codes that's over in the code folder. This is how our app looks without a well panel. If we just surround the two inputs at the top of the app with well panel, then it places them together in this gray well, which visually works very nice. It's a visual way to group things together. Shiny contains 12 functions that make different sorts of panels. Each of these group objects together, and they do something a little different with the objects. I'll let you explore these at your leisure, but we'll look at 3 of these very closely, and we'll look at some of the other ones later, because 3 of these are involved with stacking panels on top of each other. If you want to start stacking things on top of each other, then you begin with tab panel. It creates a stackable layer of elements, and inside that tab panel you can put whatever you want. It's like a small UI of its own. So you could add fluid rows and columns inside there to lay it out, or you could just drop an element in there like a graph. Every tab panel needs a title because when you start stacking panels on top of each other, you need to be able to navigate between them, and the titles go be an essential component of that navigation system. And then after you give it a title, you could give it whatever elements you want to appear in that panel. Tab panels are designed to work with one of the following functions: tab set panel, nav list panel, or navbar page. We'll look at the 2 panel functions first, and then we'll look at the page function in the next module. What tab set panel does is it combines several different panels together in a way that you can navigate with tabs at the top of the panel. So here you see we've called tab panel 3 times, and we've given each of our panels a title, tab 1, tab 2, tab 3, and we've put them together with tab set panel. In the app, you can see the titles of each of those tabs, and you can click on the tabs to actually navigate to what's in that part of the app. So there's a navigation section here to the stack, and then there's a content section. And we'll see that with nav list panel as well. If you wanted to think of our imagery here, each of these slices, each of these layers is a tab panel, and then this stack of layers is what I'm calling a tab set panel. Before we look at nav list panel, let's go over to RStudio and look at our example of a tab set panel, because I think that will really make it easier to understand. O5 Tabs is an app that It does some stuff, so I had to write some code to make this sophisticated. We don't have to go through the code, but based on the past two webinars, you'd be able to understand it. However, notice it is grouping things together into tab panels. We have 3 of them. And it's grouping those tab panels into a single tab set panel. So if I copy all this code and run it at the command line, it'll launch this app. And the app looks like this. It's just showing some normal data here. I could take a new sample of normal data. And you could use it to get a feel for how normal data actually looks when you only sample 500 objects. But this is just the top layer of the stack. There's 2 more layers behind it. And if I click on one of those, I could see that this layer, now it's at the top. It's doing the same thing, but it's doing it for uniform data. And then the final layer does it for chi-square data. Each of these layers has its own resample button. It looks like the button's not changing, but don't be fooled by that. It's just each layer has the same button in the same place. So this is how a tab set looks in practice. It's a convenient way to put a lot of things into a small amount of real estate. And then the nav list panel does a similar thing. Use it just like tab set panel, except you call nav list panel instead of tab set panel. You pass to it tab panels, and then it will display a sidebar of links next to the contents. So its navigation is a sidebar. It appears next to the contents if there's space for it. If there's not space for it, it'll move to the top of the contents, and then the contents will appear there. In all other respects, it works the same way as tab panel. And then there's an example of that there too, and we could take a look at that. That, of course, is 06 nav list. Let's run this one. And here's our same setup, but now we navigate through the sidebar. All right, so what should you know about panels? Panels are a common way to group elements into a single unit for reasons that could be functional when you're making a stack, for example, or just purely aesthetic like well panel was working. You use tab panels to create stackable panels, and then you put those panels together into a navigable stack with tab set panel or nav list panel. Now these things, as well as the row system and the column system, are all documented in this article here. So if you would prefer to go through this at your own pace, reading about it and seeing examples in code, visit this article. And then, in addition to building your layout with the basics that we just covered, Shiny does come with several pre-packaged layouts that can save you time if you want to do what they already do. And what I'd like to do is go over those for you. Probably the most common way to build a Shiny app is with a sidebar layout. And there is a layout function called sidebar layout that works together with 2 of these panels, sidebar panel and main panel, to divide an app into 2 sections, a sidebar and whatnot. The way you use it is you put the function inside fluid page, and it only takes 2 arguments, and those arguments must be the output of sidebar panel and main panel. Well, those are the 2 required arguments. There are other arguments you can find on the help page. And then when you want to put something in the sidebar, just pass it as an argument to sidebar panel. And if you want to put something in the main panel, pass it as an argument to main panel. And we do have an example of that in the slides or in the code. And if you've seen any Shiny apps whatsoever, you've probably seen an example of sidebar. So here's the sidebar. It only extends as far down as it needs to based on what you put in there. And then here's the main panel. I've put my plot there. Since this is a fluid page, the sidebar won't always stay on the side. If I make the page completely narrow, instead of trying to wedge both things in next to each other, Shiny will put the sidebar back on. We'll put it on top here. But technically, it's still a sidebar. Another approach to laying out a Shiny app is to use fixed page instead of fluid page. So you notice that our apps have responded as we change the width of our browser window. And that's because we're using fluid page. The whole point of fluid page is to respond fluidly to the dimensions of the browser window. Fixed page does not do that. It will create an app that's either 724 pixels wide, 940 pixels wide, or 1170 pixels wide, based on whatever the current width of the browser window is. So you could change the width of the window, but the dimensions of things in the app won't change so much until they make one of these jumps. Use it with fixed row instead of fluid row, not too surprisingly. And I find that I've never had a reason to use this, but it is there. In general, you'll probably stick with fluid page. And then something that you likely will use quite a bit is navbar page. So navbar page sort of picks up this idea of stacking panels on top of each other. It takes a title, it always needs a title, and then it takes 3 panels. Well, let me take that back. It takes as many panels as you want to give it. In this example, I'm using 3. Navbar page replaces fluid page. So if you were to use navbar page, you wouldn't call fluid page, you just call navbar page. And then you give it its title. And what it will do is it'll take the tab panels that you give it and assemble them into a single page that has this sort of navbar at the top of the page. You'll see your title. That title will appear all the time on the app. And then you'll see the different titles of the tabs. When you click on one of those tabs, you'll go to that place. So just like before, we could think of the navigation and the contents. But in this case, the whole page will be the contents. With tab set panel, you could conceivably just put a tab set panel in the sidebar or in a main panel or just some portion of your app. But with navbar page, the entire app is the stack. It gives the appearance that your single app is a set of multiple web pages that the user can navigate back and forth with. And if we go back to our code folder, there's an example there which shows this off very well. Let's take a look at it. It is the navbar page example. And you'll notice I'm using navbar page instead of fluid page, giving it a title. And then this is the same code as in the other app. I'm using the same tab panels and whatnot. When I run this, we get our resampling app. But now I can move between the different pieces of code up here. The next example shows off what we're going to cover in the next slide, so let's just take a look at it, because I should be better about naming these things at the top of the file. It's again calling navbar page, and it's again calling tab panels. But I'm using a helper function here, tab menu, or navbar menu. So one tab panel is directly under navbar page, but the next 2 tab panels are under navbar menu. And I've given the menu a title itself. If I run this code, I get almost the same app, but you'll notice that the navbar appears a little different. Instead of having normal data, uniform data, chi-square data, I have normal data and then other data, which, if you'll remember, was the title of my navbar menu. And then when I click on other data, I get a drop-down menu with the titles of the remaining 2 tabs. So navbar menu is a helper function that helps you put even more tabs into a single navbar. Come back to the slides, we could take a look at how that works. You could put tabs either straight into the navbar page, or you could put them in the navbar menu. If you put them into the menu, they'll show up under the title of the menu as a drop-down menu. And then finally, there's a very aesthetically pleasing prepackaged layout for you called dashboard page that doesn't come in the Shiny package, but it comes in the Shiny dashboards package. And the Shiny dashboards package contains other functions that help you create a dashboard-like layout, and even inputs and outputs that work best with the dashboard layout and don't come with the regular Shiny package. You could take a tutorial about Shiny dashboards at the link at the top of the page here, and then Winston Chang, the author of Shiny dashboards and the maintainer of Shiny, filmed his own webcast about the Shiny dashboards package just last month. So you could check that webcast out at the link below, and it's titled Dynamic Dashboards with Shiny, the webinar. All right, so when it comes to prepackaged layouts, you can use sidebar layout to quickly create a side panel and a main panel. You can use fixed panel along with fixed row to create a non-fluid Shiny app. And then you can use navbar page, perhaps with navbar menu, to create a multi-page app like the ones we were looking at. And then finally, the Shiny dashboard package provides an additional layout for creating administrative dashboards with Shiny. All right, so now we've looked at how to add static visual elements to your app, how to lay out those elements, but we haven't really looked at how you could change what these things look like once they're there. And that's what we'll look at last before we leave. And the way we'll go about this is with CSS. So what is CSS? You may or may not know that every web page you make is basically just a simple document that looks like the thing on the left here. In fact, if you have a very slow internet connection, you visit your favorite web page, you might have been surprised once or twice to find out that it looks really bad. I mean, everything's there, but it doesn't look visually pleasant at all. And that's because you're seeing the page without the CSS styling. CSS is a way to take the basic elements of an HTML app and tell your browser how they should look. So instead of displaying a piece of text, display text that is blue and uses this font and is this size. All those extra elements to the text are called CSS. And for example, if you went to Shiny Dev Center, you'd see the web page that you see here on the right, hopefully, and it's built off this web page on the left. This is what the web page looks like with no CSS. I use CSS to turn the basic elements into what we see at the end of the day. And since Shiny apps are web pages, the same approach applies to Shiny apps. Let's go over to the code and look at this stuff live. So the last example, css.html, is an HTML file that creates something when you preview it. Creates this web page. So this isn't a very spectacular web page, and actually it's very text heavy, especially for a webcast. But it's self-explanatory, so you could look at it later when you're not in the webcast. And what you'll see is, it's a web page with a title, has some text in here, and already the web page looks a little more pleasant than what you get with the basic web page, where things would be, some sort of serif font. Don't really know why for a computer, but this one is sans serif, and the colors are pleasing. And then the actual colors down here are alternating between these different shades of blue and purple and green. If we look at the code that makes this, you'll see the web page starts with a header section. So between these two tags that say head, it's a header section. And the first thing in the header section is a link, or a tag that says link, that links to a CSS text file. It's a style sheet. And the name of the file is bootswatch.cerulean.css. So this is a CSS theme that's free online from the Bootswatch project. Its name is Cerulean. Download a copy of this to my computer, which we could actually see over here. There it is. And I'm telling the web page to use that CSS to style whatever comes out of here. If I were to delete that, re-preview the web page, you'll notice everything goes back to sort of Times New Roman or whatnot. So this, by linking into the CSS file, I'm setting the CSS for the web page to go along with everything that's in that file. If we actually look at that file, you can see that it's not really that readable, but it contains a lot of styling in here, and all of this is being applied to our web page. Let's close that. Next, there's a style section, and in the style section, there's some code. This is what CSS looks like. This is saying take any tag that's an li tag and make the text purple. Take any tag that has the class blue item and make that text blue. Take any tag that has the ID dark and make that color navy. So it's very simple CSS, but you'll see there's some notation like this dot here and this hashtag. That's part of the CSS language. We could look at that further down here. So here's the first paragraph we see, the paragraph that's gray here. It just explains that we're using the basic CSS for this article. There's nothing here that talks about p tags, so this is just straight up CSS, or it's straight up text, and if it's using any CSS, it's using the CSS provided by this link. Down here we're making a list. OL is the HTML tag to make an order list with these numbers here. And each of the entries are what appears between these li tags. It stands for list item. The first list item is just using the regular CSS. Well, it's using the global CSS we've written up here. Notice I've asked list items to be purple, and this list item is purple. The second list item is not purple, it's blue. And if we read it, it would say that we're using the class-based CSS, the CSS for items of class blue item. Up here we ask them to be blue, and this one is becoming blue because we've set it to this class. In HTML, you set the class of a tag object by giving it the attribute class. The next one has a class attribute. It also has an ID attribute, attribute dark. You can see up here there is some CSS associated with the ID dark. So that CSS is being applied to this link. So it says navy, dark blue. You notice that this CSS is overriding the class-based CSS, which would make it this color, and it's overriding the list-based CSS, which would make it purple, and it's overriding the CSS we linked in way up here, which would make it gray. So we're seeing that there's a bit of a hierarchy here. We'll take a look at that in the slides. And then finally, the last one also has an ID. It also has a class, but it has style written right into the tag here. This style is CSS. And if you write style straight into a tag, that will overrule everything. We ask the type this item be green, so there it is, it's green. What does all that mean? Well, that's certainly a mouthful, and that's a lot to take in if you've not used CSS. I don't expect you to get CSS out of this webinar. There's certainly no time. There's barely time to cover what's left. But the big themes you can use to guide you as you style Shiny apps. So you style a web page in 3 ways. You could link to an external CSS file. You could write global CSS in the header under this in between the style tags, or you could write individual CSS in a tag style attribute. For example, when I said style equals color green. And then you could have CSS apply to things in different ways. You could write CSS that applies to every tag, like every LI tag. You could write CSS that applies to every class, start giving things classes. You'll notice that a lot of the things in Shiny have special classes, and each of those classes are just a collection of CSS that makes that thing appear in a certain way. And then finally, you could give individual tags IDs and have CSS match up to the IDs. In each case, the items at the bottom, if they have CSS, they'll overwrite any CSS that's inherited from above. Same on this side. And this is where the cascading style sheets comes into play. You could use one of these first level things to create global CSS, and then you can manipulate things on top of the global CSS by applying CSS in one of the second or third places. Shiny uses the Bootstrap 3 CSS framework. You could learn about this framework and see it online. It's very popular. You've probably seen it in other places. You go to this link, you can find out even more about it. But it's useful to know that Shiny CSS is coming ultimately from the Bootstrap 3 CSS framework, which means if you look at something like the output of fluid page and you see that's class container-fluid, well, that is a Bootstrap class that has a bunch of CSS associated with it. If you wanted to know about that CSS, maybe manipulate some of it, go to the Bootstrap 3 CSS framework, look up that class, search through the documentation, see what's going on there and what you can change or not change. Next, you can style a Shiny app the same way you style a web page, because of course it is a web page. You could link to an external CSS file, you could write global CSS, and you could write individual CSS, and these things will override each other in the appropriate way. Now, as you write CSS, it makes sense to write CSS that will work with the Bootstrap 3 framework, because the things you don't change will still use the Bootstrap 3 framework. All right. If you want to link to an external CSS file, you should put it in the same folder you put your images I mentioned earlier, the www folder. The browsers that your users have will need this file to create the web page just the way you want it to be. So put it in the www folder, and Shiny Server will pass on these files to the browser for them to use. Once you've done that, if you're using Fluid Page and you want to have your whole app use that CSS file, you could set the theme argument to the name of that file. So for example, if I put bootswatch-cerulean in my www folder, then I could set the theme of the app to the name of that file, and it would use all of that stuff. There's also a second way to do this. You could use the tags $head and tags $link functions. The tags $head function creates a header section for your app. Remember, the head section is where all the CSS appeared in the real web page we just looked at. Inside of tags $head, everything you put there will appear inside the header section of your web page. If you wanted to link to a CSS style sheet, then you can use tags $link to do that. Give it the 3 named arguments that style sheet uses, and then that link will be inserted into the header of your web page, and that CSS will be used. All right. The next way to include CSS is to just write some global CSS in the header. You can do that the same way. In this case, that CSS should appear between style tags. So inside tags $head, call tags $style. And then you don't want to pass that CSS in as a character string from R. You want to pass it in as HTML. So wrap what you give to tags $style with the HTML function. You could do the same thing, cutting out the tag's head and tag style by just calling include CSS on a file of CSS. Now that CSS will have to already be written and saved in that file. That file should be in your app directory. It doesn't need to be in www, because what Shiny's going to do is it's going to read that file. It's just going to copy and paste everything from that file straight into the header section. So the CSS will travel around with the web page. It will be there in the head section. That's the include CSS function. And then finally, you could write individual CSS in your tag's style attributes, which we've been doing before. We just didn't call it CSS. It was CSS. If you want to make an H1 header that is red, you could set its style attribute to color :red, which is the CSS to make it red. So if you don't know CSS, I doubt you feel more confident about it coming out of that quick lesson. But there's a free tutorial online that I do recommend. We're not affiliated with Code Academy, but I've taken the tutorial. I think it does a good job of explaining the basics of CSS and HTML. And since both these things underlie your Shiny app, they guide the way that you change the appearance of your Shiny app. This would be a good place to brush up on those things, especially if you've never used them before. They are not hard to learn. If you were making Shiny apps, you can handle HTML and CSS, but they are tedious to learn, so this tutorial does help. Finally, I've written an article about adding CSS and other things to your app. It's linked here. It goes into it at a little slower pace and it's more detailed. And I recommend you check this out if you're interested. And then also, the things we're doing with CSS are very similar to what you do if you wanted to add JavaScript to your Shiny app, which you can do. You put a JavaScript into the head of your app or the footer. And this article goes through an example of adding Google Analytics to your Shiny app using jQuery, which is a way to add JavaScript. So that's interesting to look at too. So let's just wrap up. I know we're almost done with time here. Basically, you could add CSS the same way you do it with HTML, but use your Shiny functions to do it. And if you want to look up Shiny's native CSS, look at Bootstrap 3. So now you know how to add static elements to your apps, how to lay out the elements, and how to style the elements once they're there in your apps. If you put this together with the other webinars, you know everything you need to know to build Shiny apps. You can build and share your apps, you can control the reactions, and you can now style the apps so they look the way you imagine them to look in your head. Where should you go from here? Start building your own apps. From here on out, the quickest way to learn is to just experiment and try it out. So build your own apps, share them, get them to work, ask questions. There's a Shiny tag on Stack Overflow, and there's a Shiny Google group you can find on Google. And then, of course, if you need any extra help, the Shiny Development Center is the place to go. There's a second tutorial there. There's articles, galleries, example apps, and all sorts of things to help you along the way.